we're just going to look at number 9 here. Number 9 is one where a lot of us would probably just simplify it in one step because you would know that the common factor of 12 and 16, but I think this would be a good example to show what to do with subtraction and also what to do when you don't necessarily see that right away. So first of all, when I find a common factor, I look for the variables first, and they don't have a common variable. So that means the y and bring down the subtraction too, they're going to stay the same. But I look at 12 and 16, and both of them are even. So that means 2 is a common factor. Now, some of you were like, you thought of another number, but that's okay. Let me just show you what happens here. So 12 divided by 2 is 6, and 16 divided by 2 is 8. So now I've simplified this because I've factored out a 2. But I now look at 6 and 8 and say, well, they're both even too. So I can also divide both 6 and 8 by 2 because 2 is their common factor. So 6 divided by 2 is 3. Now remember to bring the y, don't lose that, and the subtraction symbol. And 8 divided by 2 is 4. Now I know 3 and 4 don't have any common factors because they are right in line with each other. So their only common factor is 1. So those are factored out. They're prime at this point, relatively. And now I know, well, what number goes here? Well, it's not 22. And I don't add these numbers. I actually multiply them. So be careful here because 2 plus 2 would be 4. But I'm really going to multiply because remember they're factors. So factors we multiply. So 2 times 2 is 4. So now if I go back and I think, well, wow, 4 times 3 would have been 12. And 4 times 4 is 16. So 4 is their common factor. So now I've factored it with the GCF. The GCF here would be 4. That's the greatest common factor. So if I would have left it as 2 times 6y minus 8, that is a factored version, but it wouldn't be the greatest common factor. This is the GCF. So there you go. That is number 9.